In previous lessons, and we will continue to say that the definite integral, a good analogy at least, is area under the curve. But we also said that that's like only an analogy. We'd like to really tease out the difference between those two today. Recall that this is what we mean, according to this definition. And we'd like to now even highlight this. The area under the curve, under a function, if, there are a whole bunch of ifs in this statement, is the integral. And you're like, okay, huge surprise. Area equals integral. Yay. But only because we're subject to certain constraints here. Namely that that the curve here be in bold. What does it say? Oh yeah, non-negative and integral. Now both of those things are important, but the thing we haven't really investigated today yet to date is functions that drop below the x-axis. So we just avoided the issue completely so far. We just only exposed you to functions that are above the x-axis. So that is suspicious. And then integrable is not a thing that we'll really say very much about in this class. Just know that almost every function you'll ever meet is integrable. It's not like differentiation. There are lots of functions where the derivative fails to exist. You know that.
Yes.
In fact, it was a very large focus of what we've been doing this semester. It's like thinking about non-differentiability. But most functions are integrable, even ones that have point discontinuities, right? Like if you have could you integrate the greatest integer function? You sure could. I don't mean to, like, could you integrate from, we'll say that stands for the greatest integer function, from like 0 to 4?
Yes.
I think you could, absolutely. You could just calculate the area of each of those blocks. What do you get? What does that come out to be? Yeah, if each of these is 1, 2, 3, yeah, it comes out to 6. So yeah, almost every function that we've ever met is integrable. We'd have a little bit of an issue with some things. Maybe you can raise one if you like. But
what about the last point?
Yeah, that's a good question. In fact, you might have a question about like what about the area under the curve? Like how about under this function? Right? Is it okay that there's like a hole missing? And the answer is, yeah, you can have as many holes in the function as you like, and the integral comes out to be the same. Huh? Yeah. It's actually the same thing that comes up in I hate to darken the mood of the classroom by mentioning it, but it comes up in like stat when you're when someone is asking you for like what's the probability that the fish is of length like between 24 and 25, and do we have less than or equal to, or less than, or like what about that? Like what about if it's equal to or not, and those come out to be the same probability? So the answer is it doesn't matter because you're calculating the area under a curve and under the normal distribution maybe, and it just doesn't matter. What's the probability that something is between 24 and 25? If it, assume x is continuous, is a continuous random variable. Or if it's not equal to, same deal. Yeah. So that's a weird idea for integration, that if you have a hole missing from the function, that you still get the same integral. We could really go deep there. Yeah. Yeah. This is a very interesting question, and we'll return to that someday soon. Yeah. We do have an issue. We do need to think about what happens if we're integrating over a vertical asymptote, or something like that. That's for sure. And the answer is that is an issue we'll talk about, but we'll wait to talk about that. A lot of times we can resolve that issue. So the area for a non-positive region will be the opposite of this. If you're trying to calculate the area here, it turns out that the integral will come out to be negative. And we'll have to take the opposite of that. You might be thinking right now that that's like an undesirable property for the integral to have. That for functions below the x-axis, it comes out to be negative. But I think you'll very soon see that that's actually a really good property for it to have. Can you even reason, though, from the definition where this came from, why the integral happens to come out to be negative if we're below the x-axis? I think it's not hard to see. Go back to your roots here. Where did we come from? What does this actual set of symbols mean? What's negative about this? If we have a function that's down below the x-axis, why does this come out to be a negative value? Yeah, because as we go along, every time you compute that Riemann sum, and you calculate a rectangle, you're multiplying delta x, which is positive, times f of x, which is negative for this particular function if it's below the x-axis. So it does actually make sense that it comes out to be negative. And right now you might be thinking, again, that that's like inconvenient. But I do promise you that that is eventually actually the dominant and best interpretation. But right now, if you're thinking about area, that is a little bit inconvenient. You're like, well, I'd rather not report area as negative. So we'll always report negative area as being positive if we're talking about area. I'd like to now show you how you can evaluate, like that is, we'll put away almost, I think, I don't know, trying to ever use it again. We won't ever really need none anymore. We have a better function in the calculator. It's called fnint, and I'm going to show you what it does. We'll approximate this integral together. Well, you don't have to get rid of it right away.
Is this the correct, like, exact answer for approximation?
For what?
Is this not the accurate answer for approximation?
Yeah, so this will give us the exact, this will give us, this is for integration, what n-deriv was for derivatives, right? And you remember how n-deriv worked. In fact, it wasn't mystery. How did n-deriv work? It just used a difference quotient. There's no mystery there. With a very, very, very tiny h value. That's all it did. And in fact, sometimes it would give you answers like 6.000002. And you're like, come on. I know it's 6. We all know it's 6, okay? So it's doing the same thing. Again, what is it really doing under the hood? It's just written in a very, very low-level assembly code on the calculator, so it works very quickly. But all it's doing is doing what? fnint. All it's doing is adding up a whole bunch of really small rectangles. Let's just be clear that it is not magic. It just is a little more efficient than the program that was written in TI Basic for the one we gave you, right? But that's what it's going to use. It's going to use very, very tiny values and just run it. And again, you'll get sometimes values like 6.0002, and you'll have to just be like, you mean 6? It's an approximation still. It's a very good approximation. It's like a really tremendously good approximation. Yeah, Haley.
Is it using a Riemann sum? Is it using left, right, or?
I don't know. Let's look it up in the calculator, man. Can you Google that for us, actually? Look up TI-84 fnint algorithm and ask. Yeah, it's a good. That's a valid question. I don't know. It doesn't matter because it converges on the right value, so we don't really. None of us care. But we should know. All right, so this is what you're typing in if you have an old calculator. If you have a newer calculator with the new firmware, which increasingly that's more of you actually in the room, then you actually can type it in exactly as seen right here, can't you? You've got 4 fill in the blanks, 1, 6, function x, yes? If you have the old calculator, you're putting in the same 4 things, but just in this order. Function, independent variable, that's the variable integration, comma, low, comma, high. Okay, run it. Should only take a second. Did you get what I got? If you want it as a fraction, did you get this? Just make sure you can press the buttons here. This is like less about the math right now as it is about the calculator skill. Can you do this too? Your lives have been changed forever now. Make sure your friend next to you can do this as well. Everyone's good on the calculator?
Wait, so what was the 1%?
I feel like you should say it in the calculator. I wonder if
Oh my god, so great.
High school? Yeah.
Oh yeah, you can put your
Don't touch me. We could take it. Yeah, exactly.
All right, do try this one now too. Practice with your calculator here.
That was not my mission.
Negative 18, wait, what? Wait, how's the area negative? Oh, wait, they're gonna be gone. Oh, wait, just not anything else. We have more. I feel like it's on my glasses. I haven't. What?
This is my CID9. It doesn't say there. What'd you get here on this one down here? Yeah, so explain, why is that happening? What's the picture? What's going on here? Is negative 18 an answer you might have expected?
Yes, because it's negative.
Yeah, because it's below the x-axis, so yeah, of course we get a negative answer there. If someone asked you if someone asked you to evaluate this integral, the answer is negative 18. If someone asks you what is the area between this function and the x-axis, the answer is 18. Okay, so make sure you understand that. If anyone asks you for the area of anything ever, remember you always report an area as being a positive number. Okay, that's still a thing. So, oh, there's mine. That is not bad, guys. I drew that in like the exact right place. It's pretty good. Okay. Okay.
I think you should just expel it out.
All right, let's do this one here. Why is this different from 0 to 3? Let's see. I guess we just did this one. So one way you could compute this would be to say from 0 to 3, right, on your calculator. Feel free to run that command. What do you think you'll get, given the symmetry of the picture? Well, from 0 to 3. Oh, no, I think it was negative 3 to 3.
No, 0 to 3.
Oh, was it?
Yeah.
Oh, you right. Okay. Why I have a negative out front. So one way to do this would be to say the opposite of this guy, which then comes out to 18. So yes. Or how else could we do this? Well, we could also integrate not this function, but the absolute value of this function. And when we do that, you get 18 as well. So 2 ways to do this. You can try them both. There's also if you're graphing these things, yeah. Well, I think we're only going from 0 to 3, so you're okay, because that is the intercept. If we go past that, then you're going to be integrating more of it, though. You're leaving like when we have it like this. Yeah, you're calculating, you're adding up all these values above the x-axis. Just one fun feature on your calculator that you might like is this. If you go to, if you plot a function of any kind, I just chose the one we were working on, but you can do this with any function. And you put this in y2 or y1, whatever. And then on your calculate menu, I think we're finally emotionally prepared to know and to use the integral function on your calculate menu. Every other function on the calculate menu is something that you've encountered before. And now you finally have finished the list, you know what to do there. And it does the same thing as what we've just been doing. You in fact never at any time in your life need to use this feature. But it's fun because it draws the picture. Yay. And then it gives you the answer, right? So that's fun.
Wait, how do you give it the integral? How do you tell it?
It'll try it and you'll see. It'll ask you for left or right. Yeah. All right, so have we thoroughly acquainted you with some of the things your calculator has available for you to calculate extremely excellent approximations for area under the curve, for integrals rather? Fun, right? You can watch it go J it. Okay. I mean, it should do that for you. Did you try the function yet? You don't have to. It didn't do it slowly. Did you do the calculate integral? Well, then it'll ask for left, right, and you should enter 0 and 3. Yeah, do all that. Wait till morning. All right, let's evaluate negative to positive pi, the function sine x dx. Also find the area between the curve and the x-axis. So when you're ready, go ahead and do that one. Yes. Don't ever use degrees for like basically anything in this class, okay? Did you know that the derivative of sine is not cosine? If x is measured in degrees? Did you know that?
I tried it. What is it?
The derivative of sine x is not cosine x if x is measured in degrees.
Then what is it?
Well, let's convert back to radians and you can find out. You'll have to use the chain rule. You might get a pi over 180 that pops out.
It's not worth it.
I should have told you that a while ago maybe. But. So instead you have like sine of pi over 180 times x, right? If you want to put it back in radians, then the derivative of that will be pi over 180 times the sine of your angle, times the cosine. What did you get? Anyone do this? Wait, there's definitely more going on than just 0, right? Why is this happening?
They cancel out.
Because they negate
Yeah, in fact, we can. Yeah, that's right. We can actually say something more broadly here, which we'll do in a second. But so if you evaluate the actual integral, there are two questions here for this problem. The first question is, what does this integral come out to be? And the answer is 0. And then it says, also find the area between the curve and the x-axis. That is, how much paint would it take to actually paint all of this? Can someone else, so let me just make sure we hear the first question again. Can someone else, I heard a couple people saying, but people were distracted. Can someone else say why this comes out to 0 and why that's actually something that makes sense given the situation we're in, Amy?
Isn't it similar to the difference between like distance and what's the other one? Displacement.
Yes, actually.
And so the difference is when you actually calculate, it equally balances between the negative and positive areas, but then distance follows how long you've actually gone, no matter if you've gone back and forth.
Yeah, we might have taken people a little bit too deep there though. But yes, that's exactly right. Soon we will talk about distance versus displacement versus position, and you're absolutely right. By area we mean distance traveled in the context that this is like a velocity graph, versus the integral which calculates your displacement. That's very good. I was thinking way down here though, low level.
I have a bunch shallower.
Yeah, can you give a shallow answer, Jackson?
Okay,
Thanks.
so my shallow answer is that those are like the exact same thing, right? Like they're equal, but one's under the x-axis, so it's negative. And 1 minus 1 is 0.
And it's not 1 minus 1, but whatever it is.
Close enough.
Yeah, okay. Well, what is it actually? We're ready to actually, let's actually compute these separately maybe. I don't know. How are you approaching the second question? Again, perhaps there are two good answers here. Let's hear from Corinne. What's one approach? Listen, guys. Yeah, you could just do 2 times the integral from 0 to pi. What does that integral come out to, Corinne? Yeah. So each one of these happens to be exactly 2, which, by the way, is like that should be a little jaw dropping just there. You should really plumb the depths of that. You should be like, why does that come out so nicely? I've been working with the sine curve since like algebra 2, and I did not know that the area underneath one arch of it was 2. It's really remarkable that it comes out to be not like something really weird, but exactly 2. So total we have 4 though, like Corinne said. Give another way you could do this. Let's come up with a bunch of ways if we have more than 2. Okay, so you could do the integral from negative pi to pi of the absolute value of sine x dx. Make sure the absolute value goes there, though, and not on the outside of the whole integral. You understand the difference? Because what would that do? If we took the absolute value after we're done, like imagine you're doing the integral and you're like, okay, oops, let's just take the absolute value when you're done. It's too late, right? The integral you get is 0. Taking the absolute value doesn't help then, right? What you need to do is take the absolute value of the actual function, and then what are you integrating? What are you wrapping? You're like integrating under like the McDonald's logo, right? Okay, so that should come out to 4 as well. You can try any one of these on your calculator and try it and test this. They don't have another way to write it? Yeah?
Square root squared.
Okay, yeah, I mean instead of the absolute value? Yeah, I think you mean, I think we want to square, yeah, the square root of this thing squared.
Yeah.
Rather than the square root of this thing and then all squared. Does it have a negative? Yeah, okay.
Yeah.
Square it and then take the square root.
I'm saying what Cameron
Okay,
said.
all right. But we have a function that does this on the calculator, so we can just do this too. Yeah. What else was I going to say? Oh, you could break it up too, couldn't you? The integral from negative pi to 0 of sine x dx. What would you have to do to that though? Yeah, you'd have to negate it and then add to this. Does anyone want to make a conjecture? I heard someone saying something about the symmetry of this graph. Maybe a stronger conjecture. What is the integral from? Let's try to generalize this as much as possible. From negative a to a of sine x dx.
0.
Why?
Same concept.
Same concept. Okay, sure. What's the concept? What is the same concept? Yeah. Yeah, it's really about the fact that sine is odd. So I think what we're saying is there's even more of a generalization you could give, and that's that this is true. This is true if f is odd, right? If f is odd function. Yes?
Yes.
So we have some interesting things we're realizing here. What if f was even? What do you think? It wouldn't be 0. It would be, but we can at least say it's twice whatever the other integral is if someone told you that. You know, so odd evenness, as much as that seemed like kind of on the edges in other times and places, it actually does make a lot of difference when we're integrating if we know about the function symmetry in those ways. What do you think on this one? Yeah, Derek. For what? For the integral. Oh no. Yeah. So there are 2 questions on the last slide. The first is evaluate the integral. And the answer is 0. The second question asks also find the area, and the answer to that is 4. And you could do it in any one of these ways.
Okay, so there's a difference.
Yes.
What?
Yes, Johnny. Wait, where have you been? I'll give you.
I've been absorbed in the
Just take a
Okay.
picture. Take a picture and then copy it down. Or just
What do you need? Do you need more than 10 seconds?
No, I don't think a picture takes that long.
Gotcha. If f happens to be an odd function, the reason this is happening is because f is an odd function. Sine is an odd function. Yeah, x cubed. If we took x cubed and integrated it from negative whatever to that same number, the positive version, it would be 0. Yeah. Huh? Maybe not, yeah. What do you think? Here? turn to your neighbor and tell them. We don't want to spend more than about 30 seconds on this slide, but turn to your neighbor and tell them what you think.
I think it's
From A to D.
I think it would be zero because y has to be zero. Why would you know? Yeah, that makes sense.
All right, let's hear from someone. What's your opinion? Daniel, what's your opinion? Negative? Who agrees with Daniel? Who says they think it might be positive? Anyone have a third opinion?
It might be zero. I say we can't know for sure.
Okay, a four, yeah. There might be a number of opinions. Yeah, John. Maybe it's zero. I kind of have a hunch it's negative, but it's not. But you're right. That maybe they cancel each other out. Like if you think that. So what's the reasoning here? Maybe you're thinking about this area and this area being positive and this being negative. So maybe those are the same amounts. But I think it's. I'm with Daniel though. I think it looks. I like this question though because maybe there's not a definite answer at least for this. It does look like it might be a little bit negative though. Yeah. Can you write an expression for the actual area that's between this function and the x-axis? That is the sum of these three regions in area, that is. The area of those. So how would you do that? Go ahead and write it out. Maybe it says without using the absolute value function. How would you do that? Take a note from the things I just did on the last slide. Yes? You want to answer it? Well, let's write it. So what do you want to say, Amy?
Would be the area of the curve from A to B.
Which we can just write as this. Okay.
Minus B to C. And then plus C to D.
Yeah. Yeah, so minus the middle part though. But notice what a critical role the zeros of the function play in writing this expression. Okay?
Wait a minute.
Yeah.
Okay, so like, you're subtracting the middle part, right?
Yeah.
The middle part's already negative.
Exactly. So this
Wouldn't
comes
that
out to
the
be
same as
positive.
adding?
Yes. You're adding this region. The area of this is just given by the integral. The area of this is not given by the integral, though. It's the opposite of that integral, isn't it? Which is why she wrote this. And then this is just the integral. The area of that is the integral. Yeah, so this needs to be a positive number plus this positive value plus this positive value. So this ensures that this comes out to be positive.
Yeah, but why did we, okay, but like that doesn't solve the question of whether that comes out to be zero
No.
or negative.
No, well this comes out to be something positive, for sure.
Yeah.
Right. No, we have no answer yet. We still think it's negative, but we're not really sure. We think it's maybe a little bit negative.
Oh, okay. So, okay.
Yeah. No, that was not meant to answer this question up here.
What,
Two separate
how would we
questions.
answer that question?
We would actually have to have access to the function itself, maybe.
Oh,
Right? Or you could come up here and like measure really carefully.
okay.
I do have access to the function if you're dying to know. I still have the diagram saved in a file. We'll do that. Well, we can do it now. I guess we're done here. We'll go do it.
No, this is legitimate crisis. Stop. Wait. Jesus, pass me by.
I am. What would I be doing? What would I be doing? I should juggle in the pep rally. You're right. All right, are you ready? This is the moment of truth.
There's not a point in my. Oh, look at that kid go quick, damn it, wait.
But then the truth were to take the highest point on the already. Like, ooh, no point, ooh, no point.
It's negative 0.33 is the answer. Turns out.
Might as well do 0. Let me try again.
Oh my lord!
Put it on my wrist. And we're aiming it onto my lap, but you don't
Oh my lord! Oh my lord Jesus! Oh my lord Jesus! I thought we had something.
Wait, should I get started?